What's up, guys? It's LeetCoder. This is LeetCode 79 word search. In this question, we're given a board and it has a bunch of characters in each cell of the board. And we're given a word and we have to see if that word exists in the grid. For example, we're given the word C here, and we can actually see that it's in this board. If we were to go from this S to this E to this E, we have to go adjacently, and each cell cannot be used more than once. So the algorithm here is somewhat straightforward. It's kind of a brute force algorithm. We just have to go through each cell. So we start here, check if it matches the first letter of the word. It doesn't. So we go here, it doesn't. Okay, so now we're at this S here, and we see that it does match the first letter of the word. And now we have to go through and do a depth first search. So we have to search all possible branches from that S. So we first go to A. This A does not match this E. Okay, so then we go to this F. This F does not match this E. Then we go to this A. This A does not match this E. So this S did not work. And so we have to continue in our loop. So now we go to this F. It's not an S. This C is not an S. Okay, now we get to this S and we do the same algorithm. So first we try this E. It does match the second character. So now we have to try its adjacent cells. So it's only this C. It does not match that last E. So this way didn't work. Then we try this way. This C does not match E. And finally, we try this way. This E does match the second character. And then we try this E's adjacent cells. And this E matches this E here. And so now we know, okay, we actually saw all of the letters in this word. So now we can just return true. So for the time complexity, we're going through each cell. So that's M times N. And worst case, for each cell, we're going to be branching off in 4 directions for the length of the word. So let me write this down, where L is the length of the word. So in terms of space complexity, it's O of the length of the word squared, because we're keeping track of all the visited nodes in some data structure, and we have to keep that in memory L times worst case. However, if we decide not to use a data structure, and instead we can just do something like this, where we replace the already seen cell with some other character, we actually reduce the space complexity down to O of L. And so if you found this helpful so far, please give a like and a subscribe, because it really helps the YouTube algorithm. And let's get to the code. Okay, first we loop through all of the rows. Then we go through for all the columns. Okay, now we need to define our depth first search function. So let's do it here. Depth first search, and it'll take the board, the current position, the word, and also word index to see how far along in the word we are. Okay, so let's go back to our call. If self DFS board ij word 0. If that's true, we return true immediately. And at the end of the function, we'll just return false. Okay, so now we have to do our depth first search here. So first thing we want to do is if board at I and j does not equal word at word index, then we just return false immediately, because we know that the current cell does not match the current character that we're on. Now we know the cell matches the current character. So we say if word index plus 1 is equal to the length of the word, that means we can return true, because if this condition is true, that means we've reached the end of the word. So those are our 2 little optimizations there. And now here's the interesting part. We're going to do our recursive call. So we're going to say result is equal to, and it's going to be this big conditional. The first condition, if I is greater than 0 and self DFS board I minus 1 j word index plus 1, or, and we're going to just copy this. This is in the direction of going up. We're going to copy this 4 times, close out the parentheses there. Now all we have to do is change these conditions a little bit. So this way we'll be going down 1 row. Here we're going to be going left 1, and then we're going to be going right 1. And here we have to actually check other conditions. So instead of I greater than 0, it's I is less than length of board minus 1. And here it's going to be j is greater than 0. And here it's going to be j is greater than length of board at I minus 1. Okay, so now we can just return this result. And this almost works, except we're not accounting for all of the cells that we've already visited, because this condition might actually go back to a previous cell that we've already seen. So like I said earlier, we could use a set to do that and keep track of all the visited nodes and keep track of all the visited cells. But it's a lot easier and faster if we just do this. So we set board at ij to some character that's not in the character set that we're checking. So I just used the number sign. And then we'll just do this. At the very end of all of our recursive calls, we'll set it back to what it was. And so this way we avoid that extra space complexity and actually speeds up our algorithm quite a bit. And there's actually one small thing I didn't catch, and that's this greater than needs to be a less than. And that's it. So we got the right answer. We're faster than 82% of submissions. And I think that's because we didn't use this extra space complexity, which helps out a little bit. For this algorithm, you just have to know that you have to use depth first search. And you can do this recursively like I did here, or you can do it iteratively. So in this case, I thought recursion was actually easier to write and to read. But yeah, that's all there is to it. So if you found this helpful and want to see more videos like this, please give a subscribe, and I'll see you next time.